Let's do a quick recap of what we learned last time. Well, we talked about Aristotle and Galileo, and they each had different thoughts on how objects move when they're in free fall. Remember, Aristotle thought that the velocity of an object is proportional to its mass, and then it falls with constant velocity. Galileo thought that the distance an object covers is proportional to the square of the time it's been falling, or, in the case of experiments, rolling. In order to distinguish between these two viewpoints, we had to do an experiment, and we found out that data is really power in physics. And how did we distinguish between these two viewpoints? We did an experiment. Because in the world of science, evidence rules, not the ideas of brilliant thinkers. We also learned some of the equations of motion. For example, the equation which describes how far an object travels in a certain time, given an initial velocity and an acceleration. So all of these together gave us the ability to predict how an object will move, or to quantify its motion. The goal for this unit is to explain the cause of motion. We already know how to quantify and predict an object's motion, but we still don't know why an object is moving the way it is. To do this, we'll have to understand what it means for an object to be at rest. Seems like a straightforward concept, but actually a lot to learn here. We'll also have to learn Newton's 3 laws of motion, and these are the same laws of motion that you can use to send a rocket into space or put a person on the moon. We'll also be able to answer the feather problem by the end of this unit. And what's the feather problem? Well, one problem with feathers is that they're very hard to draw, so I apologize. But the problem I'm referring to is that when you drop a feather, it actually does fall at more or less constant speed, which seems to align with Aristotle's viewpoint. So we need to figure out what's going on there. Finally, we'll learn about gravity, and I'll teach you how you can use your physics knowledge to lift enormous objects. Before we get started, let's go to Cambridge University in England and talk to Dr. Patricia Farah, who's an expert in Isaac Newton and his book, The Principia Mathematica.
Isaac Newton symbolizes two great changes in the way that science was done, and in particular in the way that physics was done. He didn't do this single-handedly. He was just one of many people who did it, particularly Galileo. So there's two main reasons why his book, The Principia, The Mathematical Principles of Natural Philosophy, why it's important.